The objective of this lesson is to introduce various multiplication and division strategies students will use in 4th grade. Strategies give students opportunities to create connections between mathematical ideas and understand the mathematics behind the problem. Students develop conceptual understanding through the strategies. When students can recognize and appreciate the meaning of symbols, words, and relationships associated with one particular concept, they can connect representations of that concept to each other and use any of the forms of representation to building new ideas and solving problems. Strategies can be used in multiple ways to solve multiple problems. Strategies are the tools to mathematics. Students in 3rd grade had repeated exposure to arrays. Students would form arrays of multiplication facts. For instance, 5 times 6 would be 5 rows of 6. Having this foundation led students to understand area with an open array. Students also used tens rods to show multiples of tens. However, using a combination of units, tens, and hundreds to represent 2- and 3-digit multiplication problems is a new concept taught in 4th grade. The area model organizes students' thinking of multiplication. This method is called an area model because we are multiplying the length by the width, finding the area of a rectangle. In the problem 6 times 427, first we write 6 on the left side, then we break 427 into expanded form, 420 and 7. We can list these numbers on top. First we multiply 6 times 400, which is 6 times 4 hundredths. This totals 24 hundredths, 2,400. Next we multiply 6 by 20, which is 12 tens, 120. We then multiply 6 times 7 to equal 42. Each part of the region above corresponds to one of the terms in this computation. A student can also think of this as how many objects are in 6 groups of 427. By finding products of 6 groups of 400, 6 groups of 20, and 6 groups of 7, then adding them. The next strategy is partial product. We will solve 84 times 56. In this strategy, we will find parts of the product before adding the parts together. In this strategy, you can work left to right or right to left. In this example, we will work right to left. First, we will multiply 4 times 6 to equal 24. Then we will multiply 6 by 8 tens to equal 48 tens, which is 480. Next, we multiply 5 tens by 4 to equal 20 tens to equal 200. Then we multiply 8 tens by 5 tens to total 40 tens to equal 4,000. Finally, we add all the parts of the product. We add 24 plus 480 plus 200 plus 4,000. This method was called partial product. We found different parts of the product and added them together. Division and multiplication are correlated together. In a division problem, the dividend is the number getting partitioned into equal parts. The divisor is the number you are dividing into the dividend. In 4th grade, quotients with remainders are introduced. Students extend their knowledge of division up to 4-digit dividends and 1-digit divisors. Let's solve 966 divided by 7. We are going to view this problem as a missing side length. 966 is the total area, and we know one of the factors is 7. We then think 7 can go into 966 how many times without going over? I start off with hundreds, tens, or numbers that I can multiply in my head quickly. We know 7 can go into 966 100 times. 7 times 100 equals 700. We will subtract 700 from 966. We have 266 remaining. We then think 7 can go into 266 how many times without going over? We know 7 times 3 is 21. So 7 times 30 is 210. We subtract 210 from 266 to get 56. We then see how many times 7 can go into 56. We know 7 times 8 is 56, so I record 8. We add up the parts of 100 plus 30 plus 8 to equal 138. 138 is our missing side length. Now we can say 966 divided by 7 is 138. Another way to organize this information is to write out a division problem. I ask the same questions of how many times 7 can go into 966. I start off with 100 and record it where my quotient belongs. I subtract 700 from 966 to leave me with 266. The next step is to find how many times 7 can go into 266. We know 7 can go into 266 30 times, and we can record it above 100 and subtract 210, representing 7 times 30 is 210. We subtract 210 from 266 to leave us 56. We know 7 can go into 56 8 times. We record this as well by our parts of the quotient. Similar to partial product, we add up the parts. The parts are 8 plus 30 plus 100 equals 138. We then can say 966 divided by 7 is 138. When dividing, we are in essence finding group size. If we were to divide 744 by 3, we would be finding how big each group would be. We will draw sections to represent my 3 groups. We will think to ourselves, I have 7 hundreds, 4 tens, and 4 ones to equally disperse among 3 groups starting with hundreds. We can give each group 2 hundreds. This uses up 6 hundreds. We then can break up one of our hundreds into tens. This leaves us with 14 tens. I can give each group 4 tens. I have 2 tens left over. I can decompose the tens into ones. I have 24 ones. I share 24 ones among 3 groups evenly, and each group will get 8 ones. In all, each group received 2 hundreds, 4 tens, and 8 ones. In other terms, 248. Fourth grade is the first year students are introduced to remainders. Students will not only be introduced to the concept, but use remainders in context. We will look at different scenarios and how the remainder can be used given the situation. Van de Waal states there are 5 possible ways remainders can be used. Remain a quantity left over. Be partitioned into fractional amounts and added to the quotient. Be discarded. Force the answer to the next highest whole number. Or cause the quotient to be rounded to the nearest whole number. In this problem, 5 possibilities for remainders could apply. The art teacher has 38 ounces of clay to distribute between 4 students who are each working to build a vase. How much clay will each student get? Possibilities of remainder interpretation could be: the remaining 2 ounces may be saved for another project. Each student would get 9 ounces of clay. The remaining 2 ounces could be divided equally among the 4 students. Each student would get 9 and 1/2 ounces of clay. The remaining clay could be discarded. If not needed for another project, each student would get 9 ounces of clay. 1 or more students may get an additional amount of clay. For example, 2 students may get 9 ounces and 2 students may get 10 ounces. The quotient may be rounded to the nearest whole number, and an approximation could be used. Each student may get approximately 10 ounces of clay with none left over. Students may also encounter problems where the question is the remainder and not the whole quotient. It is critical for students to understand the problem and the question being asked. In the following problem, the desired answer is the remainder rather than the quotient. Charlotte designs and knits sweaters. Each sweater requires 4 buttons. She began the project with 107 buttons and made as many sweaters as she could. How many buttons remain after the last sweater is made? The question is not asking how many sweaters can be made, which would be the quotient, but rather how many buttons are left over, which is the remainder. Students need to contextualize their answers to ensure they understand and are solving the problem correctly. The objective of this lesson was to be introduced to various multiplication and division strategies used in 4th grade. We met our objective by using area diagrams and partial product to solve multiplication problems. We also solved division problems with an area diagram, partial quotient, and finding group size. We discussed remainders and how they may be interpreted in division word problems.